All right, this is Honors Pre-Calculus. This is section 1.7 notes. It says it at the top of my paper, but this is my second video going into these notes. I'm going to pick up where the last video left off. We're going to be talking about functions. And in the very first example, we're going to be talking about f of x, and we're going to be talking about g of x. I wanted to take a second and just kind of review what is f of x, what is g of x. So f of x or g of x, these are going to be two separate functions. Okay, those are two different functions. If I plug in x, so if I plug in x, I get out f of x. If I plug it in the other equation, I would get out g of x. If I input x, my output is f of x, or is g of x. Graphically, if I input a number, I'm inputting the x value, and I'm getting out the y value. And that would be my f of x. So my f of x is a y value if you're talking graphically. So what we're going to be doing with f of x and g of x is we're going to be doing arithmetic. We're going to add them, we're going to subtract them, we're going to multiply them, we're going to divide them. So what you're really doing is you're adding two y values together. The problem is we don't always know what those y values are. Now, if I know that f of x is 3 and g of x is 7, then I can easily say that f of x plus g of x is 10. That's easy. And you'll have some questions that you'll have to do that kind of thing with, but for the most part, we're going to talk about where we don't know the value of x. Whoops. Okay. Now, this should say example number 1. I apparently hit 3 instead of the hashtag and never typed 1.
This is a test. This is a test only.
Okay. So, anyway, I just made a I realized it didn't say example number 1 anymore till just now. So we're given f of x is 2x minus 3, and we're given g of x equals x squared minus 1. The first thing we're going to do is we're going to find the sum. And this is what the sum is going to look like. It's going to look like f plus g of x. Well, that means we're going to take f of x and we're going to add g of x. And since I don't know the value at which x it is, it's just any x, well, we're going to use this part of the equation. So I'm going to have 2x minus 3 plus x squared minus 1. I'm going to add them together, collect any like terms. I'll put them in descending powers of x. And that would be f plus g of x. The next one, f minus g of x would be f of x minus g of x. So we'll have 2x minus 3 subtract x squared minus 1. So 2x minus 3, I'm going to subtract the x squared, and I'm going to add the 1 after distributing that subtraction sign. And we will get, I'm just going to reorder it, negative x squared plus 2x minus 2. All right, next product. So fg of x would be the same thing as f of x multiplied by g of x. So we're going to take 2x minus 3 and multiply that by x squared minus 1. So we're going to distribute, and we'll get 2x cubed minus 3x squared. Oh my gosh. All right, and then we have plus 3. Make sure I hit record. Yep, okay. All right, so fg of x is that product right there. All right, and then we've got the quotient. So we're going to put 2x minus 3. Oh, oops, I'm sorry, I forgot to write the f of x part first. So I'll have f of x over g of x. Let's go this way with it. 2x minus 3 over x squared minus 1. Now, I could factor that, but if I factor it, nothing is going to simplify. So I don't really see the need to have it in the factored form. When you do this in your assignment, they're also going to ask for the domain for the quotient. So we're going to find the domain for this quotient. Remember, the denominator cannot equal 0. So x squared minus 1 cannot equal 0. So I've got x squared cannot equal 1. I square root both sides. I get x cannot equal positive negative 1. So what I could write the domain as would be negative infinity to negative 1 union negative 1 to 1 union 1 to infinity. Right, the next example, example 2, is finding the domains of quotients. So the same thing that we just did, just more practice. So we've got our f of x and our g of x, and we're going to find the domain of f over g, and then we're going to find our domain of g over f. So let's see, f over g, that is going to be square root of x over the square root of 4 minus x squared. Okay, and then for, I keep changing the color, but it's not doing it. There we go. G over f of x will have square root 4 minus x squared over the square root of x. So things that we have been learning in chapter 1 is that if we have the domain, we cannot have a square root with a negative number. That would be a no-no. Oops. That would be a red no-no. There you go. And then also we cannot have a denominator equal to 0. The denominator cannot equal 0. That is a no-no if it equals 0. I guess I should have put equals, not equal to. Oh no. There we go. So we also cannot have that. So since I have a square root on the top and the bottom, and for both of these, I know for both of these that our square root cannot be negative. Let me not write a square root. I know that our square root cannot have a negative underneath. So for the top one here, x has got to be greater than or equal to 0. For the bottom one here, 4 minus x squared has to be greater than or equal to 0. And then looking at this one, because they are the exact same numerator and denominator, just reciprocating. Oh my gosh. Sorry, I keep pausing this. Oh, nope, that didn't last very long. They keep making noises on our... Right, so for this one over here, x is greater than or equal to 0, and on top 4 minus x squared has to be greater than or equal to 0. So that's talking about the square root portion of it. There is also okay, where was I? We just talked about the radical portion of it, the square root portion of it. But we also need to talk about the denominator can't be 0. So in this denominator, we have 4 minus x squared. That cannot equal 0. Well, that's telling me that this little guy is not really there. Over here, the denominator is x, square root of x, so x itself cannot equal 0. So that's just telling me that this little thing is gone. So we still have the majority of what we wrote up there. So now I'm going to kind of think about this as being a number line. And 0 is on the number line. Let's see, for this first one, I'm going to solve this one. I'm going to get, let's see, I'm going to move the x squared over. I'll have 4 greater than x squared. I'm going to switch it all around. We'll have x squared less than or x, and then once I start square rooting and I've got a plus and minus 2 in there, it gets really confusing. So this is a part where it would be most beneficial to test values. So I'm going to test some values. I'm going to test negative 10. I'm going to test 0. And I'm going to test positive 10. And I'm testing values in between the negative 2 and the positive 2 just to see where, like, if the values are really less than negative 2 or greater than negative 2. Like, the signs over here get really confusing when you start square rooting. So I think it's just easier to test. So if we test, let's start with testing 0. That's the easy one to test. And we're just testing this in the denominator because my numerator can be 0. My numerator just can't be a negative number. So testing 0, 4 minus 0 squared gives me square root of 4, and that one's fine. So this one does work. Now, I just said that my numerator cannot be a negative number. If I test negative 10 cannot work because negative 10 is not greater than 0. So nothing down here is going to work. Also, from 0 to negative 2, none of that is going to work either because that's not greater than 0. So it has to satisfy both of these. 0 does work. In between 0 and 2 does work. It satisfies both of these. I can even check a number. I can check the number 1. Plug it in, 4 minus 1, square root of 3, or square root of 1. Those are fine. Then we can check positive 10, which is all the way up here. Positive 10 would be fine on top. If I square it, I get 4 minus 100, and I cannot square root that. So way up here in this section, none of those work. So my last question is, does 2 work? Well, if I do 4 minus 2 squared, that equals 0, but it cannot equal 0, so 2 does not work. Our domain ends up being the numbers in between 0 and 2. In between 0 and 2. So I would write that as it can equal 0, goes all the way to 2, but does not equal 2. So now my second part. So you shouldn't have as much work to do on the second part because we already worked out a lot of these. We know there's a number line. The only difference between these two situations is that the equal to and the not equal to kind of switched. So this one over here can equal 2, but can't equal 0 according to our domain restrictions up here that we wrote down. So this is what the answer would be for question B. All right, the composition of two functions. So this I typed, but in reality it looks more like F, and then there's like a little O, and then G. It's not as big as I made it look. I just couldn't find something on the computer to make it smaller. So it's F of G of X. F of G of X. And here's another way of writing it right here. F of G of X. So G of X is the output of the G function. G of X is the outputs of the G function. So if we do F of g of x, that's saying, when I have f of x, that's saying wherever there's an x, we're going to replace those x's with the outputs of the g function. So this is going to be replace x with g of x. So here's our two equations. We've got f of x, which I'm going to put in blue, whatever color this is, sorry, blue. F of x equals x squared minus 9. And I will put g of x, square root of 9 minus x squared, I'll put that in red. And what I'm going to do is I'm going to color code everything so you can see what's happening. We're going to have the f function, but wherever there's an x, I'm going to replace it with the g function. So what's that look like? My f function is x squared minus 9. So x is something that's getting replaced, squared minus 9. So there's my f function, only instead of x, I'm going to put my g function in. Square root of 9 minus x squared. And now we're going to simplify that. So if I have a square root and I'm squaring it, I'm going to, those are inverse operations, I'm going to cancel those out. 9 minus x squared minus 9. And I'm going to combine my like terms and I get negative x squared. And we're going to find the domain of this function. If you look for the domain, but you only look at the end, you're going to miss restrictions that happened earlier that you don't see in the very end. So we kind of have to start at the beginning. There are no domain restrictions for quadratic, so f of x is fine. But there are domain restrictions for square root. X is going to have a negative 3 and a positive 3 that we need to test around. So if I start testing points, I test 0, I could test negative 10, I could test positive 10. Let's see, if I plug in 0, I always start with 0 because it's easy. 0, 9 minus 0, so that one's going to work. So that's a good area. Negative 10 or positive 10, if I square them, they're going to be the same answer. They're going to be 100. 9 minus 100, that's not going to work. So not over there. So our domain is going from negative 3 to positive 3. Now it says to use the graphing calculator to check with the domain. And because I'm using the computer right now, I'm just going to show it to you with Desmos. So I'm going to type in square root 9 minus x squared minus 9. I'm going to type in before it got simplified. And then it does look like a negative x squared quadratic, but if you scroll down, you will see it stops. And it is starting here from negative 3, if we're talking about x's, the domain, negative 3 all the way to positive 3. So there's that domain restriction right there. So this could be a good way of checking it. It does also work on your graphing calculator. I just did not have my graphing calculator up on my computer. All right, almost done. The very last section is finding components of composite functions. So this is saying h of x is already an f of g of x. And we're going to go backwards. We're going to say, what could f of x, what could f of x and g of x equal separately, so that when I do f of g of x, we get 1 over x minus 2 squared. So what I would look for is, since g of x is in the inside of the function, I would look for some sort of function that is inside of another function here. And I'm thinking x minus 2 is kind of on the inside of something. So x minus 2 could possibly be my g. Now, if that is my g and I put it in place of x, then my original x has got to be down in the denominator squared. So that's going to give me an x minus 2 that replaces the x to make it x minus 2 squared. But that is not the only answer. You could have said, well, what if f of x and g of x, what if you looked at it this way, x minus 2 squared, and then f of x is 1 over x. That is another option. These are both valid answers. So when you do this in your assignment, it's very possible that I get one answer, but you get a totally different answer. They could still be the same right answers. If you have questions, you just ask me. You just ask me, hey, is my answer also okay? Because I guarantee I'm not going to be able to think of every single possibility that could possibly have ever existed. So just ask me if you got questions. So for Friday, you are, where's our thing? Is it this? Nope. Nope. Let's do it this way. Dashboard. Going back to modules. So today, I'll just do it this way. Today we had a review worksheet, and the review stuff was on the previous video. And then I will have the answer key posted, and you'll just upload your answers here. The quiz itself is going to be on Friday. It'll be partially where you type things in Canvas, and then partially like graphs will certainly be paper, and I put in quotes because that might be like Cami. The 1-7 that we did today in this book assignment, that is not due till Tuesday. So you have till Tuesday to do that. You can work on that after the after you're done with the quiz. And the YouTube video I'm making will be posted soon. And then on Friday, I haven't posted everything on here yet, but on Friday you will take the quiz. After the quiz, you'll have time to work on your 1-7 assignment, but then we are going to begin 1-8. I do not know how much time. I do not think we will get all the way through 1-8. I'm just thinking we're going to start it a little bit. There is another problem-solving assignment. You will not have problem-solving on this quiz, like that 1-3, day 3, that more challenging assignment. That won't be on this quiz, but it could possibly be on the test. So here's another problem-solving assignment that is due, and it's not due till next Thursday. So you have time to look at that. There's only 5 questions. Get help with it, whatever you need, before next Thursday. All right, have a great day. Email me if you got questions.